Okay, so I want someone to actually count how many times I either say alright so or okay so in a video. There was one time I edited these things and I was driving myself crazy. So if I'm driving you crazy, I'm sorry. But anyway, nearest neighbor and cheapest link. This is often one of the harder lessons um, for students to grasp. Um, but eventually, with enough practice, we get there. Um, so the nearest neighbor and cheapest link solve something called the traveling salesman problem, which actually is the idea of how your GPS works. It's how your GPS calculates the best way to get from point A to point B, and it does it lightning fast. We're not going to do it lightning fast, and we're going to do it in much small scale. We are not computers, we are human beings. So, what we're going to do is we're going to think about how to get from point A to point B, either costing the least or driving the least amount of miles. Um, and we're even going to talk in terms of gas mileage for your cars. Um, I know I'm poor and I like to not, and I live in a city, so I like to not drive my car as much as possible. I also live in a city and insurance on my car is high, so the more times on the road and more times I'm on the road, the more likely I am to get into an accident. So my car stays parked a lot. Um, and if it's faster for me to just walk to downtown, I will. And I take into account traffic patterns, parking costs, gas cost, all to make these decisions. And we can actually apply mathematics to these decisions. So, like in the zombie example, now I'm not going to draw anything on this because I haven't recorded this review yet, and I'm going to forget to erase these marks. In the zombies example, I had you guys starting from the safe house and coming back to the safe house. But what if and for the most part, you guys would have found the answer to the zombies activity, uh, which I'm not going to tell you here because, again, haven't recorded that yet. Future students, ignore me. I'm crazy. I don't know what I'm talking about. But I do know what I'm talking about with math. So when we did the zombie example, we looked at going to the safe house and getting back to the safe house. We made decisions about what path we were going to take depending on how many zombies were in between us and our destination. So that what you did there, oh, forget it. Is you did what we call a nearest neighbor. You picked the 8, and then you ended up at the clothing store, and then you made a decision either to go to the hardware store or no, you don't pick the 8. Oh God, I'm starting this video over. I can edit. I will edit. I will edit. I will edit. I will edit. It won't take me that long. I want to make sure I get it right. Editing it'll be faster. You picked 5. And then you were at the sporting goods store and you only had one zombie between yourself and the hardware store. So you went there. From the hardware store, you had to make a decision between 15, 49, 4, or 13. You picked 4 because that was the least amount you were facing at the exact moment in time. Then, from the gas station, you went right to the ammo store because you only had 12 between you. And you couldn't go back to the safe house because you haven't gotten more clothes. So then when you're done with the gun store, you have one more stop. So you just plow through those 17 zombies, Army of Darkness style, and then up into the 8. And you should have gotten 311 zombies. But there are other ways of minimizing this problem. So I'm going to erase this. Oh, damn. And hopefully I will have enough energy to edit this video. And you won't have to watch 30 seconds of me scribbling this out. Although I might just leave it in for entertainment value. So what if we could plan this? What if we could plan ahead? Okay? What if we could plan ahead? And since I already mapped out all of the zombies in between us, let's say that safe house run wasn't really planned out, but let's say I could plan it out. And I'm looking at the map and I can see where all the hordes are. I'm looking at the street, I can see where the hordes are, and I can pre-plan a run to see if I'm going to survive or not. Obviously, the first thing I would want to make sure I did was pick the least edge. So I've gone from hardware to sporting goods for 1. Now I want to look at this and go, where else is there not a lot of zombies? 4. I can go 4 from the hardware store to the gas station. So that was 1, that was 4. Where else can I go? 5. I want 5 in there. That's the safe house to the sporting goods store for 5. The next smallest I see is 8. And that's safe house to clothing store for 8. And I can't do 10 because I've already been in and out of sporting goods. Because we don't want to repeat. I can do 17, but not yet. I'm going to do 12. So, ammo to gas station at 12. And then my last one will be clothing store to ammo. Now, and that was 17. This is a lot less than 311 zombies. So pre-planning may save you some time and energy and maybe your life if it's, The Walking Dead. So this is 5, 10, 18, 30, 47. 47 zombies. I will take 47 over 311 any day. Bonus round aside. I mean, I play a lot of video games, but if I were to... I'm rambling. I'm sorry. I am so sorry. So, what I just modeled for you is the cheapest link. My first step was I picked the cheapest edge available. And then I marked it. And then I picked the next cheapest. And then I marked it. And I kept going without repeat until I formed an entire Hamilton cycle. The most important thing I need you to remember about the cheapest link is that you can bounce around. The most common mistake when my students are doing this activity is that they'll start with the cheapest and then start doing nearest neighbor. Cheapest link, you pick up your pencil. Nearest neighbor, you don't. Okay? So this route that we took was safe house. Doesn't matter if I go to sporting goods or a clothing store first. It's going to be the same cycle. We'll go clothing store, ammo, gas station, hardware store, sporting goods, safe house. It doesn't matter that you bounce around because you will still get a Hamilton cycle in the end. Okay? So let's do an example.